So this class we analyze the transistor amplifier using H parameters. Analysis of transistor amplifier using H parameters. So we all know a transistor is a two-port active network. That is two-port active network. So a transistor is a three-dimensional device. So by taking one terminal reference, we can apply the input at one pair of terminals, and we can take the output across another pair of terminals, so that it will act as a two-port network. So now how can we make this as an amplifier? So simply we have to connect the external voltage source and the external load apart from applying the proper biasing to the transistor. See, for example, we will apply the external voltage source Vs has got a source resistance Rs So this is 1 and 1 dash input port, then here at the output we can connect a load resistance RL. This is 2 and 2 dash. So here load means, don't assume just we are connecting a resistor. Suppose you consider a power amplifier circuit, then the external load may be a loudspeaker. Suppose we want to consider an audio system, we want to convert our sound signal to electric signal, we will use microphone, then that has to be amplified, then at the end it has to be converted to sound signal by loudspeaker. So there we can say loudspeaker is the load. So this is only symbolically we represent RL. Now we can replace this two-port active network by means of transistor hybrid model. So we are not taking any specific configuration, we will take in general, then by adding the appropriate configuration symbol, we will get the formula for every configuration. So now we replace by the proper H parameter model. So this is HI, this is HR into V2, this is HF into I1, this is H0. So now we can say this is the current I2, this is the current I1, here you can have the voltage V1 plus and minus, this is the voltage V2, and here is the load current IL. So now we have to analyze this amplifier by determining the 4 parameters: the current amplification or current gain, voltage gain, input impedance and output conductance. So let us derive one by one. So first let us take the current amplification or gain. So the symbol we can use for this is AI. So the current amplification is defined as the ratio of the output current to input current, that is given as AI is equal to IL by I1. But since IL and I2 are opposite to each other but same magnitude, we can write this as minus I2 by I1. So from the circuit this side we can write, using the circuit, we write I2 is equal to HF into I1 plus H0 into V2. See, this H0 is a conductance. If we multiply with the voltage, we can find out the current through this branch, and since it is already current multiplied by the HF parameter, so now this I2 current will be splitting into two portions. So we can write I2 as sum of these two currents, that is I2 is equal to HF into I1 plus H0 into V2. But V2 is equal to minus I2 into ZL. We can replace it by a general term, impedance. So though we consider the H parameters are real number at audio frequencies, we can take in general as impedance. So let me replace that RL by ZL. So then this is actually the V2 is equal to IL into ZL, but IL is equal to minus I2, so we can write V2 is equal to minus I2 into ZL. So making use of equation 3, equation 2 becomes I2 is equal to HF I1 minus H0 into I2 into ZL. So rearranging the terms, we write I2 plus H0 into I2 into ZL, that is I bring to the other side, right hand side, is equal to HF into I1. So I2 is common into 1 plus H0 into ZL is equal to HF into I1. So I can write now, therefore I2 by I1 is equal to HF by 1 plus H0 into ZL. So but A is equal to minus I2 by I1, so I can add a minus n on both sides, so that I will get minus I2 by I1 is equal to minus HF by 1 plus H0 into ZL. So finally you can have AI is equal to, the current gain is given as minus HF by 1 plus H0 into ZL. So this is equation number 5. 4. So, this is the expression received for the current amplification. Now, if you use a common emitter configuration, just you can add a suffix with FE and for H naught E. So, minus HFE by 1 plus H naught E into ZL is the current amplification for common emitter configuration, and in the similar way you can write for other configurations also. So, now we derive the second parameter, that is input impedance. So, this you can represent by Zi. So, this Rs is the source resistance, and if you look, we see looking into the input terminals of the amplifier, we call it as input impedance. So, the input impedance is defined by, we defined it as the input voltage V1 by the output voltage. So, from the circuit we can determine what is V1. So, from the circuit on input side we can write V1 is equal to Hi into I1 plus HR into P2. So, I can take this is equation number 5, this is equation number 6. But again, making use of equation 3, making use of equation 3, we rewrite equation 6 as follows, that is V1 is equal to Hi into I1 minus HR into, this is I2 into ZL. So, but you can write I2, but I2 is equal to minus I2 is equal to AI into I1. So, from the general formula if you see A equal minus I2 by N, so I can replace minus I2 by A into I1. Therefore, V1 is given as Hi into I1, this will be plus HR into AI into ZL. So, I have substituted for minus I2 A into I1. So, HR into AI, of course I1 is there, I1 into ZL. So, now I can write this I1 common, or I can divide by I1 on both sides. Dividing by I1 on both sides, we get Zi is equal to V1 by I1 is equal to Hi plus HR into A into ZL. Okay. So, this is the expression for the input impedance. Now, we can rewrite this expression by substituting for AI. Since AI is equal to minus hf by 1 plus h naught zl. We rewrite equation 7 as follows. That is Zi is equal to Hi minus Hf Hr Ai Zl divided by 1 plus H naught into Zl. I has merely substituted for Ai this value. So with Hr the minus Hf is there, so that this plus become minus Hf Hr into Ai Zl by 1 plus H naught Zl. Again we can modify this Hi minus, I divide by Zl on both sides, both numerator and denominator. So what I will get, minus Hf Hr by Yl plus H naught. Sorry, this A is not present because we have substituted for A this value. So I will get only into Zl. So when I divide by Zl on both numerator and denominator, so I will get minus Hf Hr by 1 by Zl plus H naught. If I divide each term by Zl, this will become H naught. This will be 1 by Zl is equal to Yl. Okay. So this is another form of expression for Zi. This is 8. So because Yl equal to 1 by Zl. Okay. Now third we will see the voltage amplification. Voltage amplification, we can represent it as by AV. So this is defined as the output voltage V2 divided by the input voltage V1. So V2 we can write it as minus I2 into Zl, but minus I2 you can write it as A into I1. So I can write V2 as A into I1 into Zl. We know that V2 is equal to Ai into I1 into Zl, because V2 equal to minus I2 into Zl. Okay, but minus I2 equal to A into I1. So if you substitute V2 equal to A into I1 into Zl, that is from equation 1 and 3. From equation 1 and 3 we can write V2 equal to A into I1 into Zl. So therefore AB is equal to Ai into I1 into Zl by V1. But I1 by V1 is the reciprocal of the input impedance. V1 by V1 is Zi. Since it is I1 by V1, we will write inverse of the input impedance. So I will get Ai into Zl by Zi. So this is the equation, general equation, and this will be the equation for the voltage amplification. Okay.